Hi and Assalamualaikum. My name is Muhammad Rashid bin Rasul. My metric number is DE 2053. So I would like to present about our industrial power system project, which is our group member will present it. And this is our team member, Jivan, Praveen, Benjamin, Shami, and me, Rashid. So for the introduction, this project design and analysis the power system network for industrial based on the requirement of the analysis, which is in assignment group. And then the suggested design is particularly meet the requirements such as simple structure, environment reliable, and most important aspect is sustainability of the network for the long term. As we know, the industrial power system is heavy system and it's highly cost. So stability system is important to make sure the system running properly in long term.
My name is Muhammad Shamil Muhammad Zainuddin. My matrix number is AE200035. So I'll be presenting for our project goals, which is our project is focuses on optimizing an industrial power system by analyzing and enhancing a network with goals like simplicity, environmental friendliness, reliability, and sustainability. So using ETAP software, we aim to improve efficiency, assess network performance, and explore renewable energy integration. So the project addresses technical issues, which is sets the key objectives and emphasizes the importance of comprehensive analysis for efficiency, reliability, and sustainability in industrial power system. So for the process is the first step is our group designs an industrial power system with simplicity and sustainability in mind by using ETAP software. So we tackle the technical issues like power flow, voltage instability, and harmonics. So the next process is we use ETAP to design and analyze industrial power systems, so addressing a power flow, voltage instability, and harmonics. In chapter 3, which is the outcomes that we provide insight into the power flow, short circuit, and harmonic analysis for both original and modified networks. And then the third steps or the third process is the short circuit analysis that we evaluate the network response to fault at 3 buses, aiding in assessing system robustness. It contributes to understanding the network's behavior during short circuits, crucial for designing protective measures and ensuring reliability. And the last process for our project is to do or analyze harmonics, which is evaluate harmonic frequencies, identifying and mitigating issues from nonlinear loads. And then the project assesses such as harmonic distortion at selected bus, and then enhancing overall understanding and aiding in effective mitigation strategies. Thank you.
My name is Benjamin Hossein. Now I would like to present about the project outcome and discussion. So for this figure is about the log flow report of original network. We can see that all the the voltage percent is above 97. So there's no so much voltage drop in this network. And the generation is always 0. And the load flow, some got the positive and some got negative. Why it caused the negative value? It's because some opposite direction from positive power. So for the ampere, all is above 40, but there's some low ampere, which is low voltage bus 1 and bus transformer 3, which one is 3.4, one is 16.4. So all the power factor is 0.8, above 0.8 lah. So for the next is the modified network. The percentage voltage is all above 98, some nearly 100. There's a very good value and no voltage, no so much voltage drop in the bus. So for the generation, all is 0 except the bus 12. For the log flow is some got the positive, some got the negative for megawatt and mega VR, which is P and Q. So for the ampere, got 3 is below than 40, which is SWGRA, 28.7. Low voltage bus 1, 3.4. Bus transformer 3, 16.3. So for the power factor, all is above 0.8 is a very good power factor. So for the next is about the low voltage bus 1 short circuit analysis. We can saw that the more we use the time, the more drop or decrease for the IDC, IENV, IAC, and IDC. We can saw all is decrease, and only the I, we can saw that the value always change, and the value is always like the sine wave, sometimes increase, sometimes decrease to the negative part. Okay. So for the next is about the SWGRA, short circuit analysis. It's the same as the before. The more the use, the time, the IDC and so on is more drop. We can see that more drop from 5 until 0 point something. Okay, for the current, you can saw that sometimes it's negative and positive. You can saw that it's like a sine wave lah, sine wave. So for the next is about the utility bus short circuit analysis. It's same as before also. The more using the time, the more decrease for the IDC and so on value. We can saw that it's always decrease a bit lah. From 2.3 decreased until 2.1. This 3 until 0 point something. For the I is like before. It's also like sine wave. Sometimes got increase, sometimes got decrease. That's all for me. Thank you.
Selamat sejahtera and good day. My name is Jiwan Jayadalan. My matric number is CE210092. So here I represent my group to discuss about the outcomes. So here we have do the short circuit analysis. So short circuit analysis helps to identify potential fault current and location in the power system. It determines where a short circuit could occur, such as between phase or to the ground. So in the ETAP, it calculates fault current that flow during a short circuit event. These currents are essential for determining the magnitude of electrical stress on equipment and for sizing protective devices. So on the first, we can see here we have the top envelope of fault current. So this is a short circuit analysis for the top envelope of fault current. We have here the low voltage bus 1, SWRG and utility bus. We can see the power for the low voltage bus, which is from 50, and it is slightly decreased and be stable at the time of 0.02 seconds. And next for the SWRGA and utility bus, it goes the same, which it takes 0.02 seconds to make the power stable. For the next one, we can see for the graph of DC component of fault current. So this short circuit analysis for low voltage SWGRA and utility bus, we can see here these three bus has same significance of power that drowns to 0 at the time of 0.1 seconds. Next, we look into graph AC component of fault current. So for these three buses, it drowns a little bit from the power, and the power is stable continuously. for the last part, we can see here for the graph of total fault current. So in this total fault current, we have low voltage bus, SWGRA, and utility bus. In here we can see the low voltage bus has higher total fault current compared to SWGRA and utility bus. So this sinusoidal wave shows individual of buses. Now I will show the simulation part. So this is our system which is designed. So before we run, we have to click here the short circuit, and then we run our system here. So this system is run completely without any error, and we run the LG first, and then we run the transit SC, and the last plot is we click to the short circuit plots. So in this plot manager, we have to select the LV bus 1, SWGRA, and utility bus, and at the left hand side we have to select all the phase A, I phase A, IC phase A, IDC phase A, IDC percent phase A, and also IENV phase A, and we can click here to the plot. So these are the graphs that we have already put in the slide and explained just now. So that's all from me. Thank you.
My name is Prainda, son of Kannan. My metric number ID is CE 210 and 202. So today I want to explain my part, which is the project outcomes and discussion, which is context system harmonics bus information. So the first one I am showing you right now is the system harmonics bus information for the voltage distribution. So we have the bus 4, 12, 13, bus transformer 1, bus transformer 3, LV bus 1, which is low voltage bus 1, SWGRA, and also utility bus, and this is the kV for the each bus, which is the 11 kV, 6.6, 11, 33, 3.3, 0.4, and so on, which is according to the PDF doctor given. And also this is the parameters, that is fun person, RMS person, ASUM person, THD person, TIF, THD person, and TSHD person, and THDG, also lastly THDS. These are the percentage for the reading for the voltage distortion for the system harmonics. And the second one is also same for the same buses, but it also for the but this one is for the current distortion, which is, for example, as you can see, they given like in the data, which is bus 4 to SGWA and bus 12 to SGWA according to the block, according to the appendix doctor given. So this is for the current distortion. And finally is for the bus tabulation is the harmonic voltage percent of fundamental voltage, which is for the LV bus, SGWGRA, and utility bus for the three main buses. So I want to show the software so I can explain more further. So these the buses I have mentioned earlier for the harmonic distortion, and for the harmonic distortion we have to run harmonic load flow first. So after we run the load flow, we can straightly go to the graph. So I want to explain more detail about the graph. So first I just select LV bus 1 and also waveforms and spectrum. So this is the total harmonic distortion for the LV bus 1 waveform and spectrum, and I go to all the spectrum. so we can see much more detail by the waveform rather than we just now see the data all. So these are the waveform for the LV bus, SGWARA, and also the utility bus. So this is the spectrum for the total harmonic distortions. So as you see, the for the current one, it says like to bus 4 from bus ID. This is the from bus ID, from bus 4 to SGWRA, from bus 12 to SGWRA, also like from bus transformer 3 to SGWRA, also utility to bus transformer 1. So these are the actually the model. So as you see, like for example, we take this one, bus transformer 3 to SGWRA. So this is transformer 1, 2 and 3. See, so from bus transformer 3 to SGWRA, the total harmonic distortion is here. So for the current distortion, so this is the value of the current distortion from bus transformer 3 to SGWRA. So on for the rest of the data also. For the voltage is also same. So that's all from me.
From this project conclusion is using ETAP software to analyze improved industrial power network is complex task with a various technical and interdisciplinary challenge. The project aims to enhance an efficiency, reliability, and sustainability of power system by addressing objectives such as power flow analysis, environmental impact assessment, design project involve carefully consideration of system function, optimizing through the testing and analyzing, and minimizing disruption to industrial operation as downtime for maintenance carries a significant loss for the company in terms of both money and time. So this is for our PLO3, which we can design the system and make the power flow analysis based on the requirement given as from the appendix as the main system, and then analyzing by uh, using the ETAP software. So thank you.